We're given a 50 microcoulomb point charge at 410, and we're asked to find the potential difference between the point 750 and infinity. Let's begin by drawing a picture. Drawing a picture helps you visualize the problem, but it also involves your sense of touch. You used your sense of touch when you were taking notes and learning. Employing your sense of touch helps you recall what you learned. Let's first recall the situation if Q was at the origin of a coordinate system, and I will use primes to designate that coordinate system. In our prime coordinate system, the electric field intensity is Q over 4 pi epsilon sub 0 r prime squared in the radial direction. The potential difference between the point at r prime and infinity is minus the integral from infinity to r prime of E dot dl. So the potential difference between r prime and infinity is Q over 4 pi epsilon sub 0 r prime, where r prime is the distance between our charge and the point where we're finding the potential. This potential difference is the amount of work it takes to move 1 coulomb of charge from infinity to r prime. And that amount of work does not depend on where you put the origin of your coordinate system. So the potential difference just depends on that distance between Q and the point where you're trying to find your potential. From our figure, we can quickly find this distance between the charge and our point where we're trying to find the potential because we have this right triangle. The magnitude r prime is the hypotenuse. This side is 3 meters and this side is 4 meters. So this distance is 5 meters. Substitute for Q, 50 times 10 to the minus 6 coulombs. Substitute for epsilon sub 0 and 5 meters for r prime. So 50 over 5 will leave us a 10 in the numerator. Our meters here cancel. 4 pi over 36 pi will leave us with a 9. And that becomes 9 times 10 to the 4th coulombs per farad. A farad is a coulomb per volt. So this becomes 9 times 10 to the 4th volts.